moving on to paper 2. So this is for the new syllabus, AAHL, paper 2, the specimens paper. I already did a solution for paper 1, so check it out if you need it. For AA, paper 2 is a calculator paper, paper 1 is a non-cal paper. So in this paper, get your calculator ready. Let's get into it. So, yeah, section A, first question, probably extremely easy. Look extremely easy, because this question also occurs in the SL specimen paper. I told you my opinion in paper 1, so I'm not going to repeat it, but it is proof that this question would be easy. The chord of length 5, so obviously, no, this is not at length, this is a chord. So look like we can do cosine rule. So let's do that. This is 4 as well. Minus 2bc cosine theta. So you need a calculator to do this. They want radian, so be careful, make your calculator into radian mode. So just casually type and do it. I don't think you need me to show you the steps. Okay, you should get 1.35 for 3 sig fig, but we'll probably need this answer for part B, so we can have a little bit more decimal places. For the area of the shaded region, so we'll need the outside angle, so it's 2 pi minus that. .9329, and therefore the area is area of a sector half radian radius square. Radius is 4, I believe. So that's it. Nice and easy. Too easy, in fact. But B, P interest compound quarterly. It's a geometric sequence. The amount at the end of each year. Find out. So we know that to calculate compound interest, the we call it future value. I think the syllabus, the formal booklet call it future value, equals to the money that you put in times 1 plus the interest rate divided by how many times you compound your interest in a year. So this is 4, and then to the power 4n, where n is the number of years. So the question is, what would be the common ratio when you go from one year to another year? So the common ratio would basically be this, because for the first year n will be 1, and then for next year n will be 2, 3, so on and so forth. So that's the same as saying for every consecutive year you would multiply the amount you get from last year by this thing, and that by definition is the common ratio. Therefore R is that thing. So I believe I need a value for significant figure. So it's 5.5% divided by 4 plus 1 to the power 4. I got 1.056 as for significant figure. Find a year that the amount will double. Well, double means the future value is 2 times of P. R is 1.056 0.056 to the power of n. Obviously, p cancel out. N is obviously log 2 over log 1.056. Some of you might even do it as this. They're the same. Change base formula. They're the same. So, what would that value be? Log 2 over log 1.056. 12.7. Therefore, it takes 13 years. Right, find the year that it occurred. Oh, it's start with 2020, so after 13 years, that should be 2033. Right? Yeah, probably. Yes, really so far. Easy, too easy. For HL Math. 6-sided die. Probability of getting a 6 is 7 over 10. Tossed 5 times. Should be obvious that this is a binomial distribution. Number of trials, 5. Success probability, 7 over 10. Find the probability that x is at most 3. So that's when you need a calculator. So get a pretty nice calculator here. Binomial n is, it should be quite similar. We probably don't have this brand. I'm not sponsored by them, by the way. It just happens to be a free app on iPad that is actually good. So I use it. X is 3. So it's 0.47178. Yeah. So you don't have to get this brand. You can use the calculator you have, obviously. B. Now you want a third 6 on the 5th toss. This question of this type, I mean, have come up in HL for, I think it came up twice at least in the past papers. So if you have done any, I mean, if you've done enough, you've probably seen it. If you've seen it once, you know how to do it. If you've not seen it before, you should pause the video now, give it some thought. How would you do this? Okay? Answer will be coming 3, 2, 1. So you want 5 toss, so 1, 2, 3, 4, 5. And you want that on the 5th toss, you had your third 6. So first of all, for the 5th toss, it has to be a 6. But this 6 has to be the third 6. That would mean that in the previous 4, there has to be 2 6s somewhere. Okay? So that actually means we need a new binomial where the number of trials is only 4. Right? Because here there's only 4 trials. And I need that within that 4 trials, I have 2 6. And then times that for the 5th toss, I need a 6. So that have to be a 6. So multiply by the probability of getting a 6. So again, I need my calculator. So, okay, it doesn't work that way. I need it to be equal to 2, I think. How do I make it equal? Yeah. Okay, 0.2646 times that. So I'll do it here. 0.2646 times 0.7. 0.18522. Okay. Yeah, I believe your calculator is similar. You don't have to use this one. Okay, finding regression line. The only thing tricky this time is usually when you do regression line, you do y on x. This time they do x on y. Okay? So basically the x is doing what y should do, the y is doing what x should do. Okay? Okay, I haven't figured out how to do with that new GDC that I just showed you. So instead, let's use my actual GDC to do it. Okay, so you type in your thing. It should be in column. So x is one column, y is one column. And then you go to, so for mine, I go to stat calculation, regression line. And then my calculator would prompt me to enter which column is x and which column is y. So for the x column, you would put in y. So you put in the value of test 2 as your x, and you should put in the value of test 1 as your y. Okay? Therefore, you're basically interchanging x and y, so you can get what the question wants. Okay, you should get a to be 1.29, well b is a negative, like this. So that's the equation that they tell you, but obviously our x and y are swapped. So this is x, this is y. Okay. B, now they want the regression line of y on x, so that's the usual way. The key is both lines pass through the same point, find it. So technically you could just ask the GDC for regression line of this. So we basically put x and y in the normal way. And then you should solve them simultaneously for their intersection. But there is an easier way. The easier way is to know that regression line always pass through the mean point. Okay, mean point being you find the mean of x, called x bar, you find the mean of y, called y bar, and the regression line always pass through the point x bar, y bar. Okay, that means both L1 and L2 have to pass through that point. So that's the point that you're looking for. Okay, so P is just x bar, Q is just y bar. So obviously your GDC would get it for you. So I got x bar to be 28.7 and y bar to be 30.3. Okay, if you don't know this, just actually solve simultaneous equation. It's not too hard. Okay, then with C, Jennifer is absent for the first test, but scored 29 for the second test. Which regression should we use to estimate the mark? Okay, so we're using the second test to estimate the first test. Therefore, it's kind of like the second test is our independent variable, which means the second test should be our x. Okay? That means we should be using L1 because the second test is in the position of x. Okay? So, well, it's technically because it's called x on y, so it's talking about how x depends on y. So that's talking about how the first test, the result of the first test depends on the second test, which is exactly the way we want to estimate in this case. So we'll put our value in the second test. So it is x equal to 1.2929. So simple calculation. You should get 27.1, 0.0, sorry, 0.01. 0.1. Okay, that's it. Okay, next one. There's a displacement from blah blah. Find the maximum distance. Okay. Well, I believe you have to graph this. So let's graph this. Okay. That's it. Did I get it right? Let's get the axis right again. 0 to 5. Okay, this is the graph. This is the displacement graph. Okay, so roughly this. So where is the largest, where is the maximum distance? Is it the maximum point? Well, the answer is no, obviously it's here. Because distance is the absolute value of displacement. So this would give you the maximum distance. So we need to find the minimum. So we'll get the minimum. Has a minimum value of negative 16.53. Then for the maximum distance is 16.513. B. Find the acceleration of the particle at the instant that it first changes direction. Okay. So apparently what we first need to know is when does it first change direction. So if you think about it, how do you know if a particle is changing direction? So you change direction if you do this or do this, right? Okay, so this is the moment that you change direction. Right at the moment that you change direction, your velocity is 0, right? Because before you change, you're going right, so your velocity is positive. After, your velocity is negative. So right between, your velocity is 0. Same thing here. So change direction means the velocity is 0. Velocity is the derivative of displacement. So that means change direction means the derivative of s should be 0. So it first happens at this maximum point. So it seems like, first of all, we need to find the maximum point. Okay, so first change direction. At x being 1.5199. But I need the acceleration, so I need s prime prime. So I need to find s prime prime when, what's this, t? When t is 1.5199. Okay. Do we have to actually differentiate this twice by hand? Probably not. Most calculators have the function of finding the numerical value of the first derivative and second derivative. Most calculators do. Can this one do it? So unfortunately, this iPad calculator do not have the function for finding second derivative. But if you're doing using Casio or TI Inspire, you probably have it. For TI, you go to the calculate page, and then you go menu, calculus, derivative at a point. So what you do is you choose the derivative to be second derivative. Right, so variable is x, the value of x is 1.5199, and then it would come with a sort of a second derivative symbol. This is where you type in your function, so type that whole thing in. And then it will say x is at 1.5199, so that's all we want. So let's type that in. Only you can't do it. Okay, so you probably don't want to buy that for your exam. Well, told you I'm not sponsored by them. Okay, I get negative 8.92. Now, if unfortunately the GDC that you are using also cannot do second derivative at a point. You would have no choice but to differentiate this thing once by yourself, and then you can use the first derivative function of your calculator to find the acceleration. Okay, that should take a bit longer than usual, but it's doable. Okay. Okay, next one, a distribution. What is that? Oh, this is the number of passengers who ride in a taxi. Opening of a new highway. Taxi company introduced a charge for passengers. The charge is 2.4 per taxi plus 1.2 per passenger. Let T represent the amount that is charged. Find the expected value of T. Wow, okay. So first, what's T? T is pretty much $2.4 per taxi plus 1.2 per passenger. But the number of passengers is X, so T is 2.4 plus 1.2x. Okay. If you remember your expectation algebra, the expectation of that will be the same as the expectation of 2.4 plus the expectation of 1.2x. But 2.4 is a constant. The expectation of a constant is just that number. The expectation of 1.2x is the same as 1.2 times of expectation of x. So all we really need to do is find the expectation of x. Expectation of x should be easy to find. You do 1 times 0.6 plus 2 times 0.3, Okay, I'm not going to write it, but I'll use my calculator to do it. Plus 4 times 0.05 plus 5 times 0.02. I got 1.59, so this is 2.4 plus 1.2 times 1.59. So it is 4.308. Cool. Now they want the variance of T. So this is the variance of 2.4 plus 1.2x. So you probably know that adding a constant has no effect to the variance, so it doesn't do anything for the 2.4. For the 1.2, you multiply the variance of x by 1.2 squared. Okay? Basically because variance is the square of standard deviation. Had it been standard deviation, you would just times 1.2. So the answer will be 1.2 squared times 0.8419 times 0.8419. So it's 1.212. Okay, nice and easy. If you know the stuff, this question is easy. Next, there are two ships relative to the origin. The position vector is given like this. Find the minimum distance. Find the minimum distance. Well, since we have a GDC, we can do brute force. The brute force method. The distance is basically the difference, right? So we do this minus this. So 7 minus 4 is 3, and then minus 3 is minus 6, plus t, this one minus this one, 0 minus 5 minus 5, that 4. Okay, so the distance is basically the magnitude of this vector. Well, this vector is really 3 minus 5t and minus 6 plus 4t. So the distance is really 3 minus 5t squared, negative 6 minus 4t squared. So we just need to minimize this, which is easy because we have a GDC. Right. Okay. I hope my GDC can do this time. Has been quite disappointing. So what do I do? Oh, by the way, if you want to minimize a square root, it is enough to minimize the inside. Okay, so I will just do the inside. Bracket 3 minus 5. So it's a quadratic. Where is the minimum? The minimum is a bit to the right. The scale is a bit crazy, but never mind. Just ask for the minimum. Minimum is when x, which is t, so minimum, when t is, well, we actually don't care about the t, well, right now. But the minimum value is 7.9024 for the inside of the square root. So now we have to root that. So root, again, I say again, if the inside is the smallest, then when you root it, that gives you the smallest. It's 2.81. That's it, minimum distance. Paper has been easy. Wait, finally, complex number seems to be hopefully going to be a bit more challenging. I hope you can see it, this little star. I think it means to conjugate. It probably means to conjugate. Find them. In the form of a plus b, so Cartesian form. How would I do it? I'll probably multiply z to this side. So w is 2I times z. So if you plug into the other equation, we have z star minus 3w equal to 5 plus 5i. And then at this point, you let z be, say, x plus yi, where x, y are real. Okay, so the conjugate of z will be x minus yi, minus 3, 2i, oh well, that's 6i, right? 6i times z is x plus yi. So we just expand. I was hoping that this question going to be harder. So we have negative times positive, that's negative, plus I times I is also negative 1, so it's plus 6y. So we collect the real part, so x plus 6y, plus the imaginary part is minus 6x minus y, I equal to the right hand side. So we have the real part equal to the real part, the imaginary part equal to the imaginary part. So we multiply the first equation by 6. Add them up. So we have elimination, right? X is gone. With 35, y equal to 35. So y is 1. If y is 1, then plug it back in. X is minus 1, I believe. So z is what? Z is x plus yi, so is x plus yi. That z, we still need w. W is 2i times z. So w is 2i times that equals to negative 2i. I times I is negative 1 minus 2. Nice and easy. Last one. Blah, find a set of value of m where the graph have no intersection. Is this the last question of section A? How easy is this? it already feels like to be a discriminant question, very suspiciously. Wow, it's so basic. Okay, with y equal to y, because we are looking for intersection, so we solve them simultaneously. So we probably multiply this problem to this side. So that's what? M plus 3 times a minus 3, so that's a squared minus b squared. So we have so it's already a quadratic. So what do we got? We got, so we minus that there. So it's x squared times 1 minus m equal to minus 9m. So we really divide it over, for the negative, we'll flip the 1 minus m instead of writing negative, so it becomes m minus 1. Okay. Yeah, I hope you can follow. I absorbed the negative 1 into the 1 minus m, so it becomes m minus 1. Wow, we don't even need the discriminant because it's just x squared. So what do we need? We need there to have no intersection. That means this equation should have no solution. So when would x squared equal to a number have no solution? That's when the number is negative, right? So question is, when is this negative? So it is negative for a fraction. To be negative is when the top is negative. So there's two ways, right? Either the top is negative but the bottom is positive, and negative over positive is negative, or the top is positive but the bottom is negative. Okay, how can the first situation occur, right? Let's think about it. If the top needs to be negative, then m must be negative. But if m is negative, negative number minus 1 is still negative, right? So this case can never occur. Therefore, the only for this whole thing to be negative, we have to have the top being positive, but the bottom being negative. For the bottom to be negative, so say therefore this is less than 0. If the top is positive, means m is positive, and the bottom is negative. So it means m minus 1 is less than 0. So m is less than 1. Therefore, overall is when m is between 0 to 1. When m is between 0 to 1, this whole thing will be negative. Then this equation would have no solution. That's when you have no intersection point. I guess they want to call that tricky or something, but it's definitely not hard. Again, it's just specimen. I don't know if that means the real exam gonna be easy. But I've said HL Math has been getting easier lately, which is the opposite of which is the opposite of SL Math. So rather unfortunate. So we'll move on to section B.